The Big Bang Theory is the prevailing cosmological model for the observable universe from the earliest known periods through its subsequent large-scale evolution. It describes how the universe expanded from a very high-density and high-temperature state and offers a comprehensive explanation for a broad range of phenomena, including the abundance of light elements, the cosmic microwave background radiation, and large-scale structure. The theory is supported by a wide range of observations, including the cosmic microwave background radiation, the large-scale structure of the universe, and the abundance of light elements. The concept of the Big Bang Theory is based on the idea that the universe began as a singularity, a point of infinite density and temperature, and has been expanding ever since. This expansion has led to the formation of galaxies, stars, and planets over billions of years. The theory also predicts the existence of dark matter and dark energy, which are thought to make up the majority of the universe's mass energy content. The Big Bang Theory has been tested and confirmed through a variety of observational and experimental methods, including measurements of the cosmic microwave background radiation, the distribution of galaxies in the universe, and the abundance of light elements. The theory has also been supported by the successful predictions it has made about the evolution of the universe, such as the existence of the cosmic microwave background radiation and the relative abundance of light elements. Despite its success, the Big Bang Theory is not without its challenges and unanswered questions. For example, the theory does not explain the origin of the initial singularity or the nature of dark matter and dark energy. Additionally, there are still uncertainties about the precise details of the early universe and the mechanisms that drove its evolution. Nevertheless, the Big Bang Theory remains the most widely accepted explanation for the origin and evolution of the universe, and continues to be a subject of active research and debate among scientists and cosmologists. Galaxies, stars, and planets are some of the most fascinating objects in the universe, each with its own unique formation process. Understanding how these celestial bodies come into existence is crucial in unraveling the mysteries of the cosmos. Let's delve into the explanation of the formation of galaxies, stars, and planets. Galaxies are vast systems of stars, gas, dust, and dark matter held together by gravity. They come in various shapes and sizes, ranging from spiral galaxies like our Milky Way to elliptical and irregular galaxies. The formation of galaxies is believed to have started shortly after the Big Bang, around 13.8 billion years ago. Tiny fluctuations in the density of matter in the early universe led to the clumping together of gas and dark matter, eventually forming the first protogalaxies. Over time, these protogalaxies merged and evolved into the majestic galaxies we observe today. Stars, on the other hand, are born within galaxies from clouds of gas and dust, known as nebulae. The process of star formation begins when a dense region within a nebula, called a molecular cloud, collapses under its own gravity. As the cloud contracts, it heats up and forms a protostar at its core. Nuclear fusion ignites in the protostar, generating energy that counteracts the force of gravity trying to collapse it further. Once the balance between gravity and radiation pressure is achieved, the protostar becomes a main sequence star, like our Sun. Stars play a crucial role in the evolution of galaxies, as they produce heavy elements through nuclear fusion and disperse them into space through stellar winds and supernova explosions. Planets, including our own Earth, are formed from the leftover material surrounding young stars known as protoplanetary disks. These disks are composed of gas, dust, and ice particles that collide and stick together, gradually forming planetesimals and eventually planets. The process of planet formation is complex and can vary depending on the characteristics of the protoplanetary disk and the parent star. Some planets may form close to their star, while others may form at a distance, leading to the diversity of planetary systems we observe in the universe. In summary, the formation of galaxies, stars, and planets is a dynamic and interconnected process that has shaped the universe we see today. By studying the origins and evolution of these celestial bodies, we gain valuable insights into the fundamental laws of physics and the history of our cosmos. The expansion of the universe is one of the most fundamental aspects of cosmology. It was first discovered by Edwin Hubble in the 1920s, when he observed that galaxies are moving away from each other at speeds proportional to their distance. This led to the realization that the universe is not static, but rather expanding. The implications of this discovery are profound, as it suggests that the universe had a beginning, a moment of creation known as the Big Bang. The expansion of the universe is driven by dark energy, a mysterious force that counteracts the gravitational attraction between galaxies. Dark energy makes up about 70% of the total energy density of the universe, yet we know very little about its nature. Dark matter is another enigmatic component of the universe. It does not emit, absorb, or reflect light, making it invisible to telescopes. However, we can infer its presence through its gravitational effects on visible matter. Dark matter makes up about 27% of the total energy density of the universe and plays a crucial role in the formation of galaxies and large-scale structures. Despite its importance, the nature of dark matter remains a mystery. Scientists have proposed various candidates for dark matter particles, such as WIMPs, weakly interacting massive particles, and axions, but none have been detected yet. Understanding the expansion of the universe and the nature of dark matter is essential for our comprehension of the cosmos. It challenges our current theories of physics and cosmology and pushes us to explore new ideas and concepts. The study of the expansion of the universe and dark matter is a vibrant field of research, with astronomers, physicists, and cosmologists working together to unravel the mysteries of the cosmos. By studying the large-scale structure of the universe, mapping the distribution of galaxies, and measuring the cosmic microwave background radiation, we can gain valuable insights into the evolution of the universe from the Big Bang to the present day. The expansion of the universe and the nature of dark matter are key topics in modern cosmology, and they continue to inspire scientists to push the boundaries of our knowledge and understanding of the universe. The evolution of the universe over billions of years is a fascinating journey that has shaped the cosmos as we know it today. It all began with the Big Bang, a singular event that occurred approximately 13.8 billion years ago. At this moment, the universe was infinitely hot and dense, and it rapidly expanded, cooling as it did so. In the first few minutes after the Big Bang, the fundamental forces of nature separated, leading to the formation of elementary particles such as protons, neutrons, and electrons. As the universe continued to expand and cool, these particles combined to form the first atoms of hydrogen and helium. Over millions of years, gravity caused these atoms to clump together, eventually forming the first stars and galaxies. These early stars were massive and short-lived, burning brightly and then exploding in spectacular supernova events. These explosions scattered heavy elements such as carbon, oxygen, and iron into the surrounding space, enriching the cosmos with the raw materials needed for the formation of planets and life. Over billions of years, galaxies continued to evolve, merging and colliding with one another, forming larger and more complex structures. Our own Milky Way galaxy is the result of billions of years of cosmic evolution, with its spiral arms, central bulge, and supermassive black hole at the center. Within our galaxy, stars continue to be born, live out their lives, and eventually die, enriching the interstellar medium with the elements necessary for the formation of new stars and planets. The evolution of the universe is a dynamic and ongoing process, with galaxies moving away from one another as the universe continues to expand. This expansion is driven by dark energy, a mysterious force that counteracts the pull of gravity and causes the universe to accelerate in its growth. As we look out into the cosmos, we see the remnants of the early universe in the form of the cosmic microwave background radiation, a faint glow that permeates the entire sky. By studying this radiation, scientists have been able to learn more about the conditions of the universe shortly after the Big Bang and confirm many aspects of the Big Bang theory. The evolution of the universe is a complex and awe-inspiring story that continues to unfold before our eyes, offering new insights into the nature of the cosmos and our place within it. The history of the universe is a fascinating journey that spans billions of years, starting from the moment of the Big Bang to the present day. Throughout this vast timeline, there have been key milestones that have shaped the universe into what we see today. One of the earliest milestones is the formation of the first elements, such as hydrogen and helium, which occurred within the first few minutes after the Big Bang. These elements would go on to form the building blocks of stars and galaxies. As the universe continued to expand and cool, the first stars began to form. These massive stars played a crucial role in the evolution of the universe, as they produced heavier elements through nuclear fusion in their cores. The death of these stars in supernova explosions scattered these elements into space, enriching the interstellar medium and paving the way for the formation of future generations of stars and planets. Another key milestone in the history of the universe is the formation of galaxies. Over billions of years, gravity caused matter to clump together, forming vast structures that we now observe as galaxies. These galaxies come in various shapes and sizes, from spiral galaxies like our Milky Way to elliptical galaxies and irregular galaxies. The formation of galaxies marked a significant step in the evolution of the universe, as they became the sites of star formation and the birthplaces of new planetary systems. One of the most important milestones in the history of the universe is the formation of the first galaxies. These ancient galaxies, which formed less than 1 billion years after the Big Bang, provide valuable insights into the early stages of cosmic evolution. By studying these distant galaxies, astronomers can learn about the conditions that existed in the early universe and how galaxies have evolved over time. The discovery of the cosmic microwave background radiation in the 1960s was a major milestone in our understanding of the universe. This faint glow of radiation is the remnant of the Big Bang and provides crucial evidence for the Big Bang theory. By studying the cosmic microwave background, scientists have been able to learn about the composition, age, and geometry of the universe. In recent years, the discovery of dark matter and dark energy has revolutionized our understanding of the universe. Dark matter, which makes up about 27% of the universe, is invisible and does not emit or absorb light, yet it exerts a gravitational pull on visible matter. Dark energy, on the other hand, is a mysterious force that is causing the expansion of the universe to accelerate. Together, dark matter and dark energy make up about 95% of the universe, with ordinary matter making up just 5%. These discoveries have raised new questions about the nature of the universe and its ultimate fate. In conclusion, the history of the universe is a complex and dynamic story that continues to unfold. By studying the key milestones in the evolution of the universe, we can gain valuable insights into the origins of the cosmos and our place within it. The study of the structure and evolution of the universe is crucial for our understanding of the world around us. By delving into the mysteries of the cosmos, we gain insights into the origins of the universe, the formation of galaxies, and the development of stars and planets. This knowledge not only expands our scientific understanding, but also has profound implications for our place in the universe. One of the key reasons why understanding the structure and evolution of the universe is so important is that it allows us to trace our cosmic origins. By studying the remnants of the Big Bang, the cosmic microwave background radiation, and the distribution of galaxies, we can piece together the history of the universe from its earliest moments to the present day. This knowledge helps us answer fundamental questions about the nature of the universe and our place within it. Furthermore, understanding the structure and evolution of the universe provides valuable insights into the formation and evolution of galaxies. By studying the distribution of galaxies, their shapes, sizes, and compositions, we can learn about the processes that drive their formation and evolution over billions of years. This knowledge not only sheds light on the diversity of galaxies in the universe, but also helps us understand the underlying physical laws that govern their behavior. Moreover, studying the structure and evolution of the universe is essential for understanding the life cycle of stars and planets. By examining the birth, life, and death of stars, we can learn about the processes that drive stellar evolution and the formation of planetary systems. This knowledge not only deepens our understanding of the physical processes that shape the cosmos, but also has practical applications for studying exoplanets and the potential for life beyond Earth. In addition, understanding the structure and evolution of the universe has profound implications for our understanding of dark matter and dark energy. These mysterious substances make up the majority of the universe's mass energy content, yet their nature remains largely unknown. By studying the large-scale structure of the universe, the distribution of matter and energy, and the expansion rate of the cosmos, we can gain insights into the properties of dark matter and dark energy, helping us unravel one of the greatest mysteries of modern astrophysics. Overall, the study of the structure and evolution of the universe is essential for expanding our scientific knowledge, answering fundamental questions about the cosmos, and exploring the mysteries of the universe. By delving into the origins of the universe, the formation of galaxies, and the life cycle of stars and planets, we gain valuable insights into the nature of the cosmos and our place within it. This knowledge not only deepens our understanding of the universe, but also has profound implications for our understanding of the world around us.